Hello, 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 hello. Check, check, check. So basically, these streams are for one animating water drops falling into cup. So for that animation, we are going to use Android and specifically Kotlin. So this is basically that only. These sessions are going to be that only. Some amount of work has been done with respect to this. So those things, I'll just first jot it down so that everyone is in the same picture. Yeah, everyone is in the same page, not picture. Yeah, let me first check whether this is actually live on the correct channel. Yeah, apparently it is correct only. Let me check whether the video is correct also. What I'm rendering currently. Yeah, even that seems to be correct. Great. Yeah. Water drops falling into cup. Yeah, that seems to be correct. Great. Yeah, so I intend this to be bigger streams, basically maybe of length more than 4 or 5 hours. But let me see how this works out. I'm not sure. Yeah. So yeah. How can we proceed from here? Maybe we'll just write down the main intention of this particular app, right? I'll just first start with a maybe the image starting point image basically, right? Yeah. Yeah, so this is a starting point image. So we can see this. So we'll be basically having this drop traveling down towards the cup. There is a collision in the cup, after which the water settles, and so maybe I'll write it down as well, right? Maybe I'll just use this image as well. I'll just copy it. Can I copy it from here? And maybe insert in this doc. Yep, this copies for sure. I'll minimize it from here. No idea. Yes, so this is the starting point image. That is fine. Uh, is overflowing. No, I think let's check this. Here. I think I'll undo this for now. And maybe ooh, first step is start off with an image of water water droplet originating from a tap and into a cup. Water travels until it hits the cup or water in the cup. Water then spreads according to algo. It can overflow as well. Droplets keep coming down on the basis of droplets keep coming down on the basis of a set frequency. Yeah, this is the yeah. This can be set as the basic things that we want to do. Yeah. One sec. Yeah. And now maybe so there is some part of the coding that is done. It's like very basic OpenGL setting up. Part of the coding is done. Maybe we can have a sequence diagram of that to be up to the mark with respect to the coding part. And then maybe we can start working on the current problem that we are facing. So this is kind of an unprepared stream. Even I'm not sure how the next problems are going to be tackled as such. But anyway, we will go with the flow. Maybe when a structure evolves as we stream, maybe then preparation can be done better as well. So yeah. Next, we'll just go through a sequence diagram of whatever the existing things that are present, right? Now, if we check the app, we can see that there are one, two, three, four, five, six screens, right? I'll just give you a basic walkthrough. Then maybe um, then maybe a, uh actual sequence diagram helps. So there is this main activity, and this we have this activity main XML, in which there is something called a water cup view. Naming could have been better, but as of now we have to live with it. Uh, so water cup view is there, and what we have to do is we have to check. Give me a couple of minutes. I'll be back. Hello. Yeah. I think yeah, this should be fine, I guess. So basically, uh, yeah, am I? Yeah. What was I saying? Yeah, we are still live. Do we have any concurrent viewers as of now? Nothing. Maybe we can put a timer as well, right? At some point of time or the other. Yeah, but we are thinking ahead. Let's first have a couple of streams in which I um, have a sense of comfort with the system. Yeah, so basically, if you're versed, you have done like at least dabbled a bit with, yeah, at least in bit of Android app development. This is the main activity. Main activity is the launcher activity basically. So and in this we are wiring it up with a main XML layout, and this XML layout has something called a water cup view. This water cup view is where we do the OpenGL rendering basically. So this is about the main activity. And if we check on this main activity, we can see that you do a find view by ID of this particular water view as water cup view, and then you do the on resume and on pause of these uh, on resume and on pause on this particular view. Now we'll go to the main thing here, water cup view. And here we can see that it is basically the view. And here we are setting a renderer for it. And this we are doing it in a water cup renderer, which where the actual OpenGL calls are being made. We are also passing context, which is being used in the water cup renderer. And if we see the renderer, yeah, what we are doing in the renderer is we are basically creating a 2D screen. 2D screen is the place in which there is the actual coordinates, etc. of the OpenGL that we are using, and then there is an draw frame, and then there is a shader that we are loading as well. So we may talk about OpenGL rendering pipeline quickly, maybe. I think that can be a good OpenGL rendering in Android. Excuse me. Rendering pipeline. There's a pipeline that is actually present with diagram of the pipeline as well. I think that will be helpful as a starting point. And yeah, there is something pretty. Yeah, let me just. Yeah. Basically, what happens is we specify the coordinates, right? As in, so uh, we specify coordinates to the OpenGL pipeline, and then in this particular case, right? In this case, is we are adding texture to those coordinates. So what I've done basically is I've drawn a. Maybe I'll write it down as well. This is the pipeline, by the way. This is for the reference and interact. In a 3D world, we specify coordinates of objects, right? That needs to be rendered. We then specify where the camera position is to capture these objects. We can specify movement of objects as well. Yeah. So the whole world is specified as a set of coordinates to the OpenGL pipeline. Then we specify where the camera is to see these coordinates, and then then this is converted. This 3D world is converted to something that is can be rendered as pixels, and we show it in the pipeline. So what is being currently done is we are having a screen. This is a 2D screen, right? So I'm just specifying a square with the help of four with the help of four coordinates, and this is being uh, uh, so in order to represent objects, we just don't directly give just the coordinates. We just give it in triangles. So the basic idea is everything can be divided in all the object services can be divided into triangles. So this is how, I mean, we'll maybe look it up in further sessions, but this is the basic idea. So I've given two triangles. One is for the lower part of the a square, and the one is for the upper part of the square if you divide it by the diagonal. Now what is happening is this will work as a screen. Also we can add textures to these triangles, and this texture is the image that is currently shown, right? So we added this particular texture to this image to this 2D screen, and now we'll process it at the level of textures. So the texture thing is basically there to simplify the life of everyone. Otherwise, we would have to even specify everything of the texture with respect to coordinates and all that. So this is kind of how the so if you see in the pipeline, uh, so I'll just say we can specify movement of objects as well. In this project, a 2D projection screen is there, which is the 2D screen, and 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 a texture is mapped onto this 2D screen. We could have done it in another way as well. We could have had a 3D object of a cup. We could have had a 3D object of pipe, water, and then we could have done processing on that as well. That is one way of solving the problem. This I found it easier, so I have done it this way. In some other cases, that might have been the optimum approach to go through. But here, we are just adding a picture on a 2D screen, and then there is one more thing that can be done. We can then so there are let me first write this through. In this project, a 2D projection screen is added at the time of vertex processing, and a texture is mapped onto this 2D screen, right? And there is something called fragment processing as well in the um, OpenGL rendering pipeline. And this is basically how we handle stuff at the um, pixel level. So now vertex things doesn't happen. Now every pixel coordinate is present currently, and you can now do processing with respect to that. Uh, yeah, if you see it in the image, yeah, this is something like this. There is a vertex specification, then you go for vertex shader. Geometry shader I have not used. And then once rasterization is conversion of the screen into pixels, and now you have the fragment shader, and you do operations on this. Yeah. Now you do operations on this basically. Yeah. So we will see how we have added these shaders into the code first. If you see the code, yeah, so we had a brief walkthrough of how the OpenGL pipeline looks like. So basically, things to notice is we provide coordinates to the OpenGL pipeline. Then we can do processing at two levels, one at vertex level and second at pixel level. Now, yeah, if you see this 2D screen is being created at on surface created. So this is being called when the view is initially created. And on every draw frame, I think this happens at a rate of 60 FPS. We can cross verify that the actual speed of how this happens. And then we do a draw on this. Now let's see what is happening in this 2D screen, which is our projection screen. So in 2D screen, if we see, there are basically how many methods? One is a draw method. There is some vertex shader code, fragment shader code, and there is a companion object, and there is an init. So in the init, if you check, we create a vertex buffer, we create a texture buffer, and we create a program, right? And we attach this vertex shader and fragment shader to the program. Yeah. So we'll just. Is there anyone in the? Yeah. One sec. Yeah. So this is how things are currently. And I took a break. Where were we? The init part of the 2D screen code. If you see, we can see that. We have added a vertex buffer, we have added a texture buffer, and we have created a shader. We have created these shaders, right? We'll cover this. And there is a draw part. In the draw, what we are doing, okay, okay. In the draw, we are passing these variables, right? We are passing these variables to the, actually we are passing these variables to the vertex shader program. And then we are doing stuff to activate the textures. And then we are passing the texture handle. We are passing the texture handle, and then yeah, basically we are doing these things. Uh, yeah, that's it. So basically, the shader code, right? The shader code that we had mentioned in this OpenGL rendering pipeline, we are passing it as strings actually. And if you see, we are loading this here, read text file from raw resource, right? And this is the resource. I've added it as, yeah, these two are the resources. and this is at the vertex level, and this is at the pixel level. Yeah. So in the draw, what happens is, in the draw part of the 2D screen, which we call on draw, from on draw of the water cup view, we actually pass the coordinates that is actually present, and then